There we go. All right. Now this time, hopefully no mistakes. 9, 27, 19. All right. So again, we're not gonna graph it. We're gonna factor it. Let's find the zeros. Okay. So the zeros, set it equal to 0. 2x cubed minus 12x squared plus 18x. And you guys already have this, so if I do it again, it's just another time to look at it. Common factor out of 2x. I'll have an x squared minus a 6x plus 9. And we all know that'll factor again into an x minus 3, x minus 3. So many equations. I got x equals 0, x equals 3 twice. And Leon, that's my double root, right? Thank you. So I'm supposed to have 3 answers. In a sense, I do. 1, and this one happens 2, 3. So I really have 3 answers, right? That's my double root, okay? So I know that it's got to finish, because if I look at end behavior, I know that cubes, any odd, x to an odd power, always looks something like that. You might have a few bumps along the way, a few little bumpies, but it always looks like this. Unless it's negative, then it's upside down. This is a cube, so it has to finish up. So no matter what on this one, because it's positive, it's got to finish like this one. So right here on its very last intersection point, it finishes up. It's got to go up, okay? Now, it's got to go through that point twice, right, Leon?
Yes.
So it goes through it like it's coming down through it, but doesn't go down through it because it goes down through twice. So instead of going down through it, it turns direction and goes back up. Do you see how that happens? Right? Now it's going to go up for a ways, and it's got to go through this point. You guys agree? It's got to go through this point. So the curve's going to come back down to go through it, and then down it goes. That's exactly what it looks like. Now we can put it in our graphics calculator if we need to, but I can do this without a calculator as long as I don't make a dumb mistake, right?
So did you just kind of guesstimate how tall?
Yeah, that's all I'm doing. And then, Jocelyn, will you back me up? Sometimes, and you can't use graphic calculus. Sometimes all you want is the shape and the behavior, right? In calculus, right? Just to make sure. And you're right, because it's the x values that you're going to be concerned with.
So when it says sketch a graph, it's just kind of like an estimate?
Right. Give me the right shape in the right place. Very well said. Yeah. So we don't know how tall it is. We could graph it and get the height. If I graphed it, I went 2x third power, subtract 12x squared plus 18x. And if I graph it, okay, it's there. I'd have to change my window to see more of it, but that's it, isn't it? Is that what we just had? Mm-hmm. Right? If I had changed my window a little bit taller, we can see a little bit more of it. Maybe if I make that at 20, right? There it is. Just exactly what we sketched in, isn't it? Right? Okay, so let's take a look at number 2. So number 2, same thing. In this case, this one won't factor. So if it won't factor, will not factor, won't factor without a whole lot of tricks, in this case we have to use a calculator, okay? We're going to have to either use Desmos or my calculator. And then I'm going to just type it in. I do know it's going to have the same kind of shape as this. Well, you can watch mine. Yeah. So y equals, let me put it in, x to the third, subtract 8x squared, plus 11x plus 20. So if it won't factor, we're going to have to graph it. So if I go ahead and graph it, let me change my window slightly, okay, and go a little taller. Window, a little taller. Let's go maybe 30 and graph it, okay? Now, I'm pretty sure that I've got zeros at -1. See them? At 1, 2, 3, 4, and 5. So it tells me that this will factor, but it would take some tricks. And I know the tricks. You don't need to know the tricks, okay? That's not a part of this class on how to factor these. You saw some of the tricks yesterday, didn't you? They're pretty crazy, aren't they?
Yeah, they're cool.
Yeah, they are cool. So then I know for sure I have x-intercepts at x equals -1, x equals 4, and x equals 5. So we found the zeros. These are my zeros at -1. I've got a 0 at 1, 2, 3, 4, and I've got a 0 at 5, okay? So it looks like it goes something like this. I also know I have a y-intercept at 20. I know that. You guys agree? Y-intercept of 20. You good on the 20? Has to go through 20. Y-intercept of 20. So the graph looks something like this. It goes through, up, down, and up. Okay. All right. X cubed, 3 zeros. Correct? X cubed. We got 1, 2, 3 answers, right? And it has that shape. If it's an odd, it's got that shape where it ends going to infinity and then goes down towards negative infinity. Okay, so it has that exact behavior. Okay, how am I doing? Good?
Yeah.
Okay, are you ready to turn the page?
Yes, sir.
I'm glad our calculus kids are here because they definitely agree that you gotta know this. If you're gonna take calc, you have to know this. Yep. Okay.
You're not gonna take calc.
Well, then don't worry about it, right? So now, again, here's an x to the 4th.
Screw it.
And I know there's 4 answers, right? It won't factor. It would take, I could probably get it to factor, but it would take some real sophisticated tricks. You don't need to know those.
You
Okay.
ever break it down?
Yeah, I'd break it down the same way. So what I'm going to do is just put it in my calculator, okay? So y equals,
Wait, how do you know if it's one that's good for factoring or not?
well, it probably does, but it doesn't look like anything easy to factor. Like the multiples of 12, that don't looks like I can't group them. It doesn't look like any tricks we know, right? There's some tricks I know, but this is not a college level algebra 2 course, right? Mm-hmm.
So if it has like 6 different variables, can you group them into 3 different groups?
Yep, yeah, you can. You can do that. Yep, absolutely.
Because if they have 4, we can group into 2 groups.
Yep.
Okay.
Absolutely. There's so many tricks to factoring, and the more math you take, the more sophisticated you get, hopefully.
I'm going to take a calculus 5.
I like it. Okay, and graph. So if I take a look at this graph, and I might have to change my window slightly. Looks like I'm going to have to change my window. So I go to my window, make it be a little bit more negative. Whoops, my window. Window, let's see, a little bit more negative, like maybe negative 20. Let me graph it now. There it is. Oh, down a little bit further, right? Window, even further down, right? Negative, maybe negative 30. Let's try it. Negative 30.
Oh, no.
Oh, even further down. Window, how about negative
100.
negative 50? Let's go negative 50. I like, and if that, we'll try 100. Okay, graph. Oh, I'm close.
Negative
70?
70.
Okay, negative 70. Let's try negative 70. Ah, here we go. All right. So if I need the zeros, I've got 0 equals 10x to the 4th minus 11x cubed minus 42x squared plus 7x plus 12, right? And I know that there's 4 of them, but I can't really tell. For instance, look at this one here. There's 1, 2, 3, so it's in between, so it's not exactly 3. It doesn't even look like 3.5. So we need to grab this one. And there's a feature, okay? Do you see this blue button that says calc? Inside of here, there's a calc button that says zeros. So I'm going to show you how that works. So if I go to my second blue button, calc, and I'm looking for zeros, right? There it is. I'm looking for zeros. Okay? And I push enter. Now, it says left bound, right bound. Everybody watching? So if I want to find this zero, see where my finger is? Just say left of it. Well, left of it really is above it. Does that make sense? And this is right of it. Right of it's really below it. You want to go left of it, right of it. So I'm going to put my cursor here above it, which is left of it. Lock it in. I'll put my cursor on this side below it and lock it in. Okay, let's do that. We got to find all this. So I go straight to my left bound. So let's go to the left of it. So I'm at the left of it now. Enter. Right of it. I'm at the right of that point now. Enter. Guess. I'm not going to guess. So I'm telling the calculator, hey, I've got a 0. Look right in here. See, it's got little arrows in there. So look right in here. And it is right in there, right? So guess. Push enter. Boom. What do I get? About negative 1.50. Hey, hey, hey. Negative 1.56. So one of my x-intercepts are negative 1.56. Okay, now there's 4 of them, right? So we'll do the same process again. Let's go calculate 0, right? Okay, and let's go and try and find left bound. So I'm at the left of it. Are you with me? I really am. Here's my 0 right there, and I'm on the left of it, right? blink, 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 hit enter, locks it in, okay? Enter, boom, locks it in. Boom, boom, boom. Okay, even though I'm above it, I'm still to the right of it. Does that make sense? Okay. Blink, blink, blink. Push enter, lock it in. Guess. There you go. So hey, this is actually a nice number. It's negative 1/2, right? So the other one is at x equals negative 0.5. Okay, so let's find the others. So same process. Calculate, right? Calculate the 0. Calculate my 0, enter, and I'm going to go to the left-hand side of it, which is actually above it. Does that make sense? I mean, you know, here's my point, right there. On the left of it, it's above it, but it's really the left of it, right? Blink, 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 push enter, locks it in. To the right of it, which is really below it, right? But it's still to the right of it. Enter, lock it in, guess, and I get a 0.6. Okay, so the other 0 is x equals 0.6. And the last one, same process, calculate my 0, enter, and then the left-hand bound is below it, right? Whoop, 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 nope, 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 there you go. So even though I'm below it, I'm still to the left of it, right? Right, yeah. So enter, locks it in. And then I'm going to go above it, really is to the right of it, right? Enter, enter, and I get an answer of about 2.56. So that's one more method of getting zeros, okay? So, you know, let's say you're in a test, and it's something super easy to factor, and you cannot factor. You can always graph it and get the zeros from the calculator, okay? It's a handy way to do it, okay? Does that make sense? So if I want to graph this now, I'd go my 1, 2, 3, 4, right? And I'd go my -1, -2, and again, I don't care about the height. We just need the shape. I've got a 0 at -1.56, which is about there. I've got a 0 at -0.5, which is about there. 0.6 is maybe about there. 2.56 is here, and I've got a general shape of it. Now, let's go back to end behavior, okay? And now, the end behavior on this makes a lot of sense. I know because it's x to the even power that they look like this. Okay, now this one's got a few bumps and squiggles in it, doesn't it? It's got bumps and squiggles because of all the extra terms. Every time you throw an extra term in, it just makes it whack out a little bit, okay? It makes it do some crazy stuff, but the end behavior is still the same because at the end it's going to go off to infinity, and it's going off to the negative infinity, it's going up to infinity, and sure enough, we can see that on our calculator, right? The end behavior is the same. There's a few bumps in between, but really the end behavior is consistent, so we just got to go like this. We go, okay, let's go ahead and graph it. Something like this. And again, I'm not worried about the y values, just as long as we get a decent look at it. And it's going to go here, and way down there, and then up there. Okay, how's that? So, conclusion. We have two nice techniques for finding zeros. One is factoring. For me, factoring is the easiest. It is. For me, factoring is easy because it's accurate, okay? Two, we have the calculator. Now, the calculator is not always accurate. I think you guys have seen weird answers from the calculator, right? Have you ever seen weird answers? The calculator does not do math. The calculator does not do math. It just gets closer and closer and closer and closer and says, hey, here it is. And sometimes the calculator is wrong, but the math was never wrong. Math is never wrong. It's always right.